Catherine, can you hear us?
I can hear you fine.
Way, we got there. Wonderful. Technical problem solved.
You can hear me?
It's a little...
Okay, yeah, there was...
Yeah, go ahead, Catherine. Please shoot.
Okay, wonderful. All right, well, I thank you for your patience with us as we work through all of that. I'm very happy to be here. And I'm going to go ahead and share my screen so you can see my presentation. As I'm bringing that up, there is a QR code embedded in the presentation that you can use to download it. We do ask for a little bit of information as part of that, but of course, we don't know what you put in. So I will get it out.
Catherine, just we don't have your slides on the screen, so we're just seeing your video.
Yes, exactly.
Okay.
But so you should have them now. See them now. Okay, good. We're all good. All right. Okay, so there is a QR, but I'm going to turn my own sound off because I'm hearing myself, and that's a little disconcerting.
Yeah, we can't see your slides still.
So you should be able to hear me.
I can hear you. We can't see any
if you
slides.
Can't, because I can no longer hear you, so I don't hear the echo. Oh, all right. So I'm really happy to be here. As I said, I had wanted to be here in person, but we just scheduling and things kind of didn't work out in the end. But I am happy to present this to you. And the talk of this presentation is called We Can Accelerate Net Zero because we've actually done it. And I want to talk a little bit about why we think about why there's a problem and what we have done to solve it. So, all right, so just a little bit about me. I'm the author of 4 books on innovation. The material that I'm covering today mostly comes from my second book, which is called The Shortest Distance Between You and Your New Product, with a little bit also gets physical, which is an explanation of how we use agile principles to accelerate physical product development. And I know that most of you may not be making a physical product, but I think that there's some similarities between the work that you're doing and the work that we're doing with things like solar energy companies and new battery technologies, that I think that you'll get some value from hearing how we approach these problems. So the Rapid Learning Cycles framework is a synthesis of a lot of thinking that went on in the 2000s around how we use knowledge to new things, how we use knowledge to foster innovation, and agile management practices. So if you have experience with agile in the software realm, you use these agile principles to accelerate development. We use similar principles to accelerate the development of things where agile doesn't fit. And I'm going to talk about that explicitly in the presentation. All right, so that's really what it's intended to do. And it's optimized around acceleration. It's optimized around accelerating the time from idea to launch for those things where the agile software development practices don't naturally fit. And we've actually done this successfully. So that's why I feel confident in the title of that presentation, because we've already done it. There's just some examples here of clients that I've personally worked with or who have worked with our affiliate network that are bringing solutions to the market today that are reducing greenhouse gas emissions, that are improving this company's ability to meet its sustainability goals. And one of the ones that I'm most proud of there is the work that we did to accelerate the Maxian solar energy platform for SunPower. That was so successful, they ended up splitting the companies off and turned SunPower into solar energy leader. We do, the things that I'm telling you have a basis in reality. We have example after example of how we've done this. So I want to just do a little bit of alignment first. So net zero is the state of balance where we are able to either sequester or reduce the amount of emissions that we still produce. All right, that's achieving what they call net zero. And it is a fairly controversial concept, but the main thing, the reason why I'm sharing it is because, we have two sides to that equation. We have the one side, which is we need to reduce emissions as much as possible. We need to change the sources of energy. We need to eliminate the use of fossil fuels except where absolutely necessary to produce things that we may not be able to produce in any other way right now. And on the positive side, we need to find better ways to store carbon, to sequester carbon that are coming out of the atmosphere. And then we know we're going to need at least some of that. And I'm directly involved right now in a project to accelerate a direct air carbon capture technology. So we're going to need all of those things in order to achieve net zero. The goal in the Paris Agreement was to achieve that by 2050, with the hope that if we did that, we'd limit global warming to 1.5 degrees C. Unfortunately, we're not on target for that. And early emissions are more harmful than later emissions because of cumulative effects. And so we need the solutions that we have as fast as possible. Because what happens if we fail? So right now we just announced that 2022 was the worst year for carbon emissions that we have ever had. So we're not going in the right direction, we're going the opposite direction. And yet, and the likelihood is that we will experience a 1.5 degree warmer year, warmer than the baseline, in this decade. So we're going to blow through the targets that we've set for ourselves if we don't change what we do. And it's going to be a big challenge because decarbonization is the biggest engineering challenge we have ever faced. It addresses everything: the food that you eat, the clothes you wear, all the products that you buy, everything that you see in the built world will have to be done differently for us to achieve these goals. Concrete is one of the most used materials in the world. The process of producing cement today, the core ingredient in concrete, inherently emits greenhouse gases. It inherently emits carbon dioxide. A lot of people working to solve those problems. We need that solved as fast as possible. And all around everything else, we are going to need new solutions to many of the things that we take for granted today, because we will not be able to sustain the emissions that they produce. When we accelerate the development of these technologies, we actually improve that technology's ability to carbon emissions. We actually increase its impact. And we do that because those early emissions are more valuable in the long run than later emissions saved. And we're able to pull in the point in time when that technology is commercially viable, when that technology can scale, when that technology can perhaps become ubiquitous and replace the technologies that are in use today that we can't sustain in the long run. And so this is what my mission is. My mission is to get the word out to the teams working in these areas to say that there are ways to do what you do faster. And if we can do that, then we can make a difference faster. Because we can't make it if we do what we've always done. Most of the technologies that we need today are still early stage. We don't have an economically viable carbon capture solution, not yet. We're working on it and we will get there, but we're not there yet. We reached a major milestone in 2019 when the cost of solar energy became lower than the cost of coal for the first time. We need to accelerate the time that we need to accelerate our progress towards hitting those major tipping points, because it's those major tipping points that are going to drive the adoption that we need. And yet, if you look at historically what we've been able to do, more than 40% of new products are deemed to be disappointments. That means that they didn't hit their sales goals, or they didn't achieve the performance targets, or they were not as economically viable for the company that released them. 51% of manufacturing-based startups fail. So we're going to have things differently if we want to achieve these targets. All right. So what is happening here? What's the problem? What we need to do to fix this depends on the problem. And I would argue that right now, the way that we're approaching the development process is a key source of the problem. All right. Because many people are dividing themselves into one of two camps. All right. So if you work for an electric utility or a construction company, you are probably very comfortable with traditional project management. And if you're in an environment where you have high cost of change but low uncertainty, that's exactly where you need to be. So if I'm the project leader responsible for installing a network of level 3 chargers for electric vehicles, in a city, then the technology at this point for those is fairly well known. There are things they can do to allow for future expansion and adoption of new technologies. But in general, the process of building one of these charging stations is pretty well understood. And in that case, traditional project management is perfect because it helps you optimize your timelines. When you know what to do, you can optimize it, right? On the other hand, a lot of you are operating in a space where you've got very low cost of change. If you think about, an app for calculating carbon footprints, that app can be very agile in how it's developed. You can release changes as often as the Apple store will allow you to upload a new app version. I mean, so you can iterate on that very rapidly. But the problem is that the things we need to solve climate change, and some of the things that you need to do to help ensure that your infrastructure becomes is robust and scalable enough for you to achieve what you want to do, is high cost of change and high uncertainty. Once we've established the rules for a carbon marketplace, for example, it's going to be hard to change those rules because companies are going to make decisions based on those rules. And if you change them too often, they're not going to trust you anymore. And then it becomes something that they abandon because they can't rely on it, right? For physical products, we make changes to the electrical grid. Those things are very hard to undo once they're done. And so what we've done is we've developed an approach to address that part of the high cost of change and high uncertainty. And we found that when we approach that problem differently, we consistently see reductions in the time it takes from idea to launch of 30% or more. Okay, so that's what I'm going to be sharing with you today. And this is really what's happening with the problem. So with this type of project where you have high uncertainty and high cost of change, the cost of change is not static. The cost of change increases over time. So as you go from early research, in a lab proof of concept, you can do almost anything. But when you start interacting with customers and making promises with them, you start seeing higher cost of change. As you go to commercial products, you get things that are out in the field support, your cost of change goes up even more. And so it's not easy then to take the new information you're gathering and get it and put it into the decisions you're making, because you can't iterate on it as fast as you can if you have low cost of change. And what happens as your cost of change goes up is your design freedom goes down, right? So again, in early research, I can do anything. When I have a first customer demonstration, they're probably going to be more flexible with me, and they're going to be able to allow me to make changes in their product as I learn more and understand more, but they're not going to want me to come every day or make changes every hour, right? Once I have commercial products and I've started making promises, I have to keep those promises. Once I have a whole product out in the market, I'm now supporting an ecosystem, and change becomes even harder. And the knowledge that we need to make those decisions doesn't keep pace with this. All right. So we learn a lot in the lab and we learn a lot from our first customer demonstrations. But as we begin to put products out in the market and we get more and more of them out there, that's really when we begin building more and more knowledge. And so, and the way that most people approach things, the way most people think about it, the knowledge is pushed way far to the right, which is that they don't gather knowledge about things early. They gather it late. They gather it after decisions have already been made, right? And this is what is causing these problems. So, because when you make decisions there's a point, there's a graph like this, right? So you are working on a project, you're gaining and building more knowledge about that product. You're also making decisions. And at least here in the US where I'm based, we tend to have a bias that if we're making decisions, we're taking action. So we should be decisive. We should just go forth and make decisions and implement them, fix the ones that are broken. But the problem is that when we make decisions without the knowledge needed to make good decisions, we have the risk of having to go back and change that decision later. And if you're making software and the making a change just involves uploading a new version of the app, well, that's not that bad. In fact, it's better to go ahead and do that because you're going to learn a lot from the app that's just out in the world and interacting with real users. But if I'm building something like a nuclear power plant, the decisions that I'm making have long-term consequences, and it's not going to be quite so easy for me to go back and revisit those decisions later. So what we do differently is two things. First of all, we pull learning forward to identify and remove obstacles, and we push decisions later to preserve flexibility. All right. So we're pulling learning forward so that when we get to a point of time when we need to make a decision, we have better knowledge. We have the best available knowledge. So we have much more likely to revisit that decision later. And then we are pushing decisions later, which does two things for us. One is that it gives us more time to learn. But the second thing it does is it allows us to preserve ability. So a concrete example of pushing decisions later to preserve flexibility is ensuring that your products are more modular, right? So if I'm in charge of installing that network of electric chargers, I want to make sure that the core technology in those chargers is modular, and that as a better system comes along, I have the ability to go back and update that the software allows over-the-air updates, so that as the software team improves it, I don't have to visit every charging station to update the software, right? Um, the hardware components, I may need to ensure that the connection is modular, so that as the connection improves, we can, um, we can continue to revise and update those charging stations. There may be parts of the interior of it that may be something that I may want to replace, like the controller. I may want to be able to replace that, right? So that's one way that we can preserve flexibility by pushing decisions later. And central to all of this is that not all decisions need to be pushed later. What we're looking for when we're evaluating a project to figure out how to accelerate it is we're looking for those key decisions. We're looking for the decisions that are both high cost and high risk. Okay, so for the charging stations, the thing that's the highest cost and the highest risk is that's the highest cost is bringing the power to the site from wherever it is. The thing that's the highest risk is putting a charging station in the wrong place and then no one's using it. And so those are the decisions that a person in charge of that project might want to consider as key decisions and do some early learning around. Because once they've installed the electricity, it's going to be hard to move the station. They can replace the station, but it's hard to move it, right? And so really thinking through what are those key decisions, because those are the ones that are the source of the long slow loopbacks that make these innovations take so long to get to market, right? So we're looking for those key decisions. And we're doing something very specific with those key decisions, which is that we're looking at the right people, the right time, the best available knowledge, right? So for each of these key decisions, we're really trying to focus on making a good decision at the right time, usually later than we think, with the best available knowledge, which is as much as we can gain before the decision needs to be made. So groups using rapid learning cycles think a lot about who are the right people to make a decision? When is the right time to make the decision? What's the last responsible moment, in fact, that I can make this decision? And what knowledge do I need to make that decision with confidence? And when we do that, we find that we push the learning forward so that we're gaining knowledge ahead of when decisions need to be made. We are increasing design freedom because we are delaying decisions. And every delayed decision gives us a little bit more time. So there's a little bit more design freedom that we have with those delayed decisions. And when we do that, we bring the cost of change down, which gives us the ability to make changes as we learn. And as we release new technologies, we can be able to update what we've done to make so that the solution that we have can have the maximum impact because it reflects that best available knowledge, right? So key example of this, and then I'll finish here, is SunPower and Maxion, and one of the things we did for them. So I started working with them when they were in the process of starting to build the fab that would produce the Maxion chips, the Maxion solar energy cells. And one of the things we realized is that we didn't need to know who we were going to sell them to. Okay, so product development 101 says that you need to know who your product is going to sell to. You need to know the market for your product. But here's the thing. When they were building the SunPower systems, the solar energy market was rapidly changing. And they didn't know who was going to buy these. Was it going to be grids, utility grade solar energy generation stations? Was it going to be homeowners putting solar panels on their roof? Was it going to be places like Amazon putting solar panels on their warehouse? Was it going to be all of those, right? They didn't know, but they didn't need to know. Because once you've got the solar cells, you can package them in lots of different ways for lots of different kinds of systems. And in the meantime, what you know is that solar cells need to be as efficient as possible and as cheap as possible. So you need to optimize around performance and cost, right? So the long lead time items, where are we going to build the fab? What manufacturing equipment are we going to buy to put into the fab? How will we test the solar cells to make sure that they're delivering the performance that we're promising? Those are all decisions that have long lead times that need to be made early. The decisions about who we sell this to, how will we package it? What kind of systems will we integrate this into? Those were all decisions that can be made later. All right. When at the time they got to about 2019 and they were ready to make those decisions, it was very clear that for the Maxion solar energy platform, high-end residential and commercial was probably their best fit because they don't have a lot of land. You think about a homeowner, even with a high-end home, they've got a limited amount of space on their roof that's got adequate sun exposure for solar. And they want to generate as much power from that real estate as possible. So it's okay if it costs a little bit more if they can generate more power. Versus utilities, which are going to purchase large plots of land and fill it with cheap solar panels because they know that they have the land. They're worried more about the total cost, and they're worried less about how much efficiency of energy per square foot, right? And so Maxion found its sweet spot. But if they had tried to figure that out 5 years earlier when they were building the fab, they were almost certain to be wrong. Right? So that's what we do. We look at what decisions do I need to make, when do I need to make them, and we work to make those decisions at the right time. So imagine what it would happen if you could bring your solution to the market 30% faster. If you could drive adoption of your technology 30% faster, what would that do for the impact that you're able to have on this large problem we have, climate change? And in order to get there, what I'm going to challenge you to do is to think about where are your key decisions? Where are your high impact, high unknown decisions? And what can you do to make them more resilient so that they don't have to be revisited later? All right, so I think that that's time for me. And so I have my books. I have the QR code where you can download these materials. All right, thank you so much for having me.
Wonderful. Thank you very much, Katherine. Round of applause, everyone.
I'm going to turn my sound back on.
Cheers. Thanks very much. We're going to go straight into the next talk. We're right on time now, so I'm afraid we don't have time for questions, but thank you very much, Katherine.